Okay, we're going to commission a Kinetix 350 drive using Allen Bradley's Studio 5000 software. The first thing I'm going to do here is go to RS Links Classic, and I'm disconnected from the regular internet because otherwise the communications get a little screwed up. And so what we're going to do first is we're going to create a new driver, and the driver I'm going to use is an Ethernet IP driver. I'll just click on that, and then we'll click the Add New button. Next thing here is once we've added the new driver, we can go in and just set the default. We'll just use the name that they give us. We'll use the default driver. And once I've set up the driver, now I have Ethernet IP1 and IP2. We can go ahead and close that. We'll close RS Links. It runs in the background. And then we'll open Studio 5000. I'm going to start a new project. The new project I'm going to start is an L18 ERM BB1B. The reason we're using the L18 ERM is because ERM means that it can accept a servo motor drive. If it does not have the ERM on it, you won't be able to put axis of motion on that particular PLC. We're going to go ahead and name this. We're going to name it Servo 2. And the little red box there means that you can't save it without with a space on the end of it. We're going to be revision 24, and I'm going to have one expansion module on here. We'll just go ahead and click Finish then. It will go ahead and grind along for a moment. Splash screen will show up, and then it will bring up the, here it says that it hasn't been successfully activated because I disconnected from the internet, so it can't find a license at the moment. It's okay, it runs in grace period. I can just go ahead and close this. So it will set up my new project. Here's my start page. We're offline right now, and the first thing we're going to do is go to the Servo 2 controller. This is just the actual controller, the L18, and we'll click on the Date and Time button and Date Time tab and enable time synchronization. This is very important. That way the drives know that that is the clock that they're supposed to watch, so they can move information around as quickly as possible. Go ahead and apply that. The expansion module I don't really need right now. We'll just go ahead and leave that. So I hit OK. And then we'll go down to the Ethernet and we'll add a new module there. Under Ethernet, I'm going to type in Kinetix 350. You can also click on the box in the top of the module type category filters and disable everything else and only leave the servo drives, but this is just a faster way to search for what we want. What we're going to use is an L33 PR1LM. It's a 2 amp, 240 volt Allen Bradley drive. The Kinetix 350, so we'll go ahead and create that. We'll give it a name here. This is Axis 1, and there's a space on it. You can name them pretty much anything you want. Next thing here is we need to go in and give it an IP address. Now I've already commissioned the IP addresses on these drives. This is drive number 109, so it's 192.168.1.109. And then we're going to change the revision on it. Revision number is very important because that way it knows that it's a compatible module and you can go ahead and use it. The revision number on this particular drive, something you'll have to go to the drive itself and find out what the revision number is a 1.57. So we'll go ahead and put in 1.57. That's the same for all the drives here in the lab, so we're good there. And then that should be it. We'll hit OK. Now there are some on the tabs here. My associated axes won't show up. None of that will show up yet because we're not actually online yet. You're just putting these into your project. So we'll go back into the Ethernet, put in another new module, and it'll be another Kinetix 350. It's going to be Axis 2. Of course, you can use any one of these different drives. These are all Ethernet capable. The 2097V33 is just the Kinetix servo drive, so this will be Axis 2. Go ahead and change the revision number on it. Again, it's 1 and then the 0.57 here. Hit OK. And then we'll put the IP address on it. Oops, I guess I missed the IP address there. We'll go ahead to the private network. You can put in the 192.168 if you want, but this is 110. There are several different drives in the lab here. If you have a different set of drives, of course, you're going to have to use that. Now what you need to do is add these two drives, or you need to add two drives to the ungrouped axes. Ungrouped axes are the drives, but they're not in any particular group yet. It's very important that you add those to the to an ungrouped axis first. Otherwise, it won't let you commission the motors. So we'll go ahead and add a new drive to the ungrouped axis. This will be axis 1. As you see, there's no space on that one. It doesn't really matter what you name them there. It's a base type tag. It's just an Axis CIP drive. That's all there is to it. Hit create. And you will have an axis 1 in your ungrouped axes tab. You can put in another drive here for axis 2, of course. Now, as I said, the ungrouped axes are simply drives that you created in the project that aren't necessarily tied to anything yet, but we're going to commission them so that axis 1 is connected to axis 1 motor, and axis 2 is connected to axis 2 motor. So here we go to associated axes. It shows now that I have axis 1 and axis 2 in my drives tab. So I'll go ahead and hit axis 1 and then just go down and click OK. And same thing for axis 2. Just double click on that. It'll bring up axis 2. You can go ahead and, like I said, we can run through the tabs here, but none of these will show up yet because we're not actually talking to the drive yet. So the port configuration will show that it can't auto-negotiate and all of that. But when we go back to the axis, it will show axis 2 is the other available new axis, so we'll just hit OK there. So now I have two drives that are associated with axis 1 and axis 2 in my ungrouped axes tab. Now I need to go up to my motion groups and put in a new motion group. So my new motion group, now this is where the drives will reside, as far as the PLC is concerned. It's going to be axis 1 and 2 is the name of the axis group that I'm putting together. Again, it's a base tag, so you don't have to change anything else in that tag. And now I can double click on my axis 1 and 2, and it shows unassigned axes. So these are my unassigned axes. I hit the click on axis 1 and hit add. It will send it to the tag, and then both of these drives have now been added to my axis 1 and 2. As you can see, they've moved from the ungrouped axes into my motion group. So now the motion group, I can have these two talk to each other. I can set them up however I want. So the first thing I need to do here is under the tab number for the actual drive is set up a catalog number. It has data sheet or catalog number. I'm going to click on catalog number under the pull down and change the catalog number. Again, you'll have to go to the motor itself, find the catalog number for that drive. This one is a TLY-A220. And it's actually an A220 T-HXX2 is the drive type. I'll just scroll down through the list. It gets you pretty close, and then you can find the one you actually want. So here's my A220 T-HXX2. On the motor itself, it will say H562 or something like that, but they leave the center 2 out. They just X out those two numbers. So here my axis 2, same thing. I go to my motor, nameplate data sheet, change that to catalog number. Go to catalog, change catalog, and it brings up the catalog number that I could use. There are several different motors, obviously. Again, it's a TLY A220. T-HXX2. Now, I'm not typing in the proper number here, so one of the things we can do here is we can go in and we can pull down the filters. We can go ahead and filter out all of the 460 volt motors. We can go to the the TL-A family, the TL-Y-A or the TL-AR. We'll use the TL-A. That's the one we're going to be using here. And then we can go to feedback type. I don't remember what the feedback type was, so I tried one of the A data B, and it doesn't work. So I'll just go back to the HXX2, and that's the motor we're going to be using. So we'll just hit OK there. And then I'm not zoomed in properly here or something. The OK tab won't show up on this particular screen until I jostle it around a little bit. So I had to kind of push things up out of the way. So once I hit OK, it'll go ahead and grind along here for a moment. And then it will go blank. I can double click on the download button. Oh, I failed to go online with the controller because I haven't selected a PLC yet. So what I need to do is go into my Who Active tab, click on that. It'll bring up the RS Links driver that we just built, Ethernet IP2. IP2 will show the two drives, and the PLC. So I'm going to select the PLC, which is 192.168.1.64. Shows that it's an L18 ERM BB1B. So that's the drive that I want, or the PLC that I want. And I'll set the project path and download. Don't go online, or it will just bring back the project that's already out there. You need to download this to the PLC. So then it asks if I want to download it. It wants to make sure if the drives will stop when you try and download and all that. So yes, this is all information that I'm okay with. So I'll hit OK. It'll download everything there is to know about the PLC. And it will ask me if I want to go back to run mode. And I do want to go back to run mode because that's just where it is. I didn't really think about it. But actually it works better if you put it back into program mode, because then any programming that you've written in run mode won't try and override the motor test and everything to get the drive set up and ready to go. So we'll just go back to program mode and double click on Axis 1. It'll bring up the axis for me. And what I'm going to do is I'm going to double click on the hookup tests and click the start button here. And it says that press initiates motion, and what it will do is it will just kind of grind along a little bit for about 5-10 seconds, and then it will ask you if it went the proper direction, and you can just click yes. If it didn't, I suppose you would tell it to reverse and try it in the other direction. I can double click on the auto tune, and before I hit start I actually have to go down here and set a travel limit, and we'll set that to 5, and a speed, we'll set that to 5 also. These are pretty arbitrary. You can set them to just about anything. You don't want to go too high, because if your motor's not doing what you want it to do, it will overspeed and kind of freak out. This will just be a little click. So once you get done with that test, you can move on to some other tests. And one of the tests here, you can go do some hookup tests if you move the screen up a little bit. And you go to manual tuning, and the manual tuning here would be, we're going to go to a motion axis jog. The motion axis jog is simply turning the motor on, and so we're going to set that to a speed of 5 units per second. And we'll go ahead and execute that, and it tells me that I have an error. It says the command tried to execute on an axis whose loop is not closed. All that means is I haven't turned on the axis yet, so what I'll have to do is a motion axis fault reset. We'll execute that, and it says no error down here. That's good. So we'll go ahead and close this screen, and we'll do a motion servo on. We'll execute that, and it says no error. So now we can go into our motion axis jog. Motion axis jog, when you execute that, your motor should be spinning at 5 RPM or 5 units per second. I'm not sure exactly what the RPM is there, but it's 5 units per second. So it just jogs along until you tell it to stop. So here we're going to do a motion axis stop. We'll execute that, no error. And now our motor should be stopped. We can go into a motion axis home, execute that. And all that does is it just sets wherever the motor is right now as the home position. So when we go into our motion axis move, it will know where the start and end point is. Actually, that's not exactly where I want it, so I'm going to go ahead and do a motion servo off. motion axis stop, and we'll have to do a motion servo off before we can actually set the home position, because the motion axis stop will actually hold us in whatever position the motor was in. So here's my motion servo off. We'll execute that, and now the motor should be able to freewheel. And we'll set that manually back to the home position, or set the 0 at the top. And we'll go ahead and set a motion axis home. Turn the motion servo back on. Execute that. Motion axis home. Execute that. And we'll go to axis 2, and we'll do the same setup there. So here we'll set the travel limit and the speed. We'll set those both to 1 in this case. And it's going to fail here because I haven't actually commissioned the drive yet, or haven't reset it. So when I hit the start button, it will just say online command failed and drive is not in the correct state to allow the current operation. I can just click OK here, and it will send me to, I'll just double click on the motor itself, and now we can go through these tabs. It'll actually show us what's going on with the drive. Here it shows that we have the drive online. Here's the module info. It just shows that it's an Allen Bradley CIP drive. It's configured, it's owned, and it is a match, and there are no major faults, so it should be good to go. However, let me go to the Internet Protocol here for a moment. It just shows that it's drive number 110. And what I'm going to do is reset the module. And when I reset the module, it'll set that back to 0. Your drive will start flashing 0 and the IP address. And then once it gets done with that, it will go ahead and go into, it should work its way back to 4. And you should be able to do the servo drive tests, the auto tune, and the motion axis jog and gear.